Hello and welcome in section 2. This is image classification with Keras, and in this video we will introduce you to the ImageNet dataset and also to VGG model. And we'll get started with just having a look at our example neural network. This is an example convolutional neural network that we've seen in previous section. And in case of image classification, we have our input is image because we're working with computer vision, and our output will be the probabilities that our image is actually belonging to a set of classes. And in between we have a specific neural network architecture. In case of image classification, this is usually a convolutional neural network, and I'll get into a little bit more details in a moment. So the process of image classification is really, when it comes to using it, is really that we have an image at our input, and then we have some kind of model, and it's usually a deep convolutional neural network model. And by deep, as you remember from the previous section, it simply means that we have a lot of layers inside our model. And this model, in case of image classification, has to be able to recognize two or more classes. And what kind of classes and how much of those classes really depends on the dataset. And our output will be for each of those classes that our model supports will have the probability that our image belongs to this class. So this is the basics of how in practice image classification works. So for example, let's have our robot here, and let's say that we have our model. And once we use our model on our input image, we'll have a set of probabilities, like our model say that we have 10% chance that this is a human and only 5% that this is an animal, right? So it really depends on the number of classes that model supports, and also how well it recognizes any given class really depends on a data set. And here's the big problem when you try to build your own image classification model. Models that give practical results, those results that you can compare with the human performance, are really deep. So again, by deep, I mean that they have a lot of layers in between. Layers to train, and that simply means that to train your own classification model, you need to have a couple of things. So first, you need to have time, because the more layers we have in our model, the more time you need to train them, because usually you have to have a quite large data set to actually make that happen. And then you of course have to have some kind of resources, so computer that can handle that, and usually this is a some GPU power, especially when it comes to working with images. So GPUs, graphical processing units, and those are processors usually available in your graphical cards. Some laptops and some computers, they have graphical cards that contains those powerful GPUs that you can actually use with Keras. You have to have some kind of resources, and also you have to have good and relatively big data set to train your image classification model on. And the big problem about all of this is that it really, each of those points depends on a specific problem you're trying to solve. So there's no really any kind of general about that, because you'll have a lot of nuances depending on the problem you're trying to solve. And it really all boils down in that it all takes time, right? This is the bottom line. And the solution for that, especially at the beginning when you're just starting out, is to use a pre-trained models. And pre-trained models are a convolutional neural networks that have been trained on a specific data set that we can use out of the box without any training. And we know that they perform well because they are based on some well-tested CNN architectures, and we can pretty much just get those models and use it for our image, for classification. And a lot of state-of-the-art models are trained on ImageNet dataset. This is very popular dataset for image classification. So what's ImageNet dataset? So this is basically a large visual database, and there are about 14 million images inside this database, and they were all categorized by hand. So someone actually looked at those pictures of each of this picture and put a label on this picture. So looked at a picture and said, okay, this is a dog or this is a cat. So this is actually verified by human beings. And we have around 20,000 categories or classes inside this ImageNet dataset. And this dataset allows people to compete between each other, or institutions to compete between each other to actually find the model out there. And one of those popular models that come up out of those competitions based on challenges from this dataset is VGG models. So those are a deep convolutional neural network models developed by Oxford Visual Geometry Group. Those models were one of the key image classification competition in 2013, and they were trained to classify 1,000 categories from ImageNet dataset. So this is quite a lot of categories that we can use, and it actually applies to a lot of problems. And it really depends on what kind of problem you're trying to solve. And even though those models are no longer state of the art, because each year there's a new challenges and we have new winners and there are changes in that, but still this is a very powerful set of models. And what's really important, especially at the beginning, is that you can really quickly get started with them using Keras, because there's a really easy way of going about using them Keras.